So here we will discuss about the finite automata and its uses in industry. So let's begin. So at first we have to know what is finite automata. So finite automata is nothing but the simplest form of machine which can recognize any patterns. It's a machine for using it's a machine which is used for pattern recognition actually. Within the input taken from the character set, we have to take a character set, and from that character set we have to give him the input and we can get the desired output. So finite automata actually consists of 5 things, which are q, summation, q0, f and delta, where q is the finite set of states, summation is the set of the input symbols, q0 is the initial state, f is the set of final states, and delta is the transition function. And delta is defined as delta is equal to q into summation arrow q. Now we have to know about the types of the finite automata. So the types of the finite automata are deterministic finite automata and non-deterministic finite automata. So at first the deterministic finite automata or DFA. So in DFA, the machine goes to one state only for a particular input character. DFA does not accept the null move. Okay. In deterministic finite automata, we know for a specific input character, we know about the final output. Okay. There are, for a specific input, there is only a specific output state. Okay, there are no multiple outputs for there are no multiple outputs for a single input. Okay, there is only one output for a single input and we know that output. Okay, so in here we have taken a list of list of strings which are starting with 0, like 0 0 0 0 1 0 0 0 etc. Okay, now here a here we have to know which is the initial state. So the initial state is defined as an arrow. Okay, so here there is an arrow before the initial state, so we can know it is the initial state. And for the final state, we have double circles, like here a is the initial state and b is our final state. Okay, so if in a, if we give 0, then it goes to the final state b, and after reaching b, if we give 1, then it creates a self circle. Okay, and it remains in the final state b. But if we give 1 in the initial state a, then it goes to an other state called c. Okay, so here c is the dead state. C is called the dead state or the trap state. Let us know it with another examples, like here 0 0 1. Okay, the initial state is a, so from a, if we give 0, then we go to b, then again 0, then if we give 0 in b, it creates a self loop. Okay, so it remains in b, and now if we give 1, so here is 0 1, so it again remains in the b, which is the final state. So as we can reach the final state, this string is accepted. But in case of 1 0 1, this string is not accepted, because if we start from the initial state and we give 1 to a, then it goes to c. Okay, here we have 1 and it goes to c. Then if we give 0, it again remains at c, which is not our final state. Then again 1, it remains in the c, which is not our final state. So this string is not accepted. Now we will know about the non-deterministic finite automata. So in non-deterministic finite automata, the given current state, there could be multiple next states. Okay, in deterministic finite automata, the next states are already determined. There is only one next state. Okay, but in the non-deterministic finite automata, there can be multiple next states. Okay, so the next states may be chosen at a random, and here the null state is accepted. But in deterministic finite automata, the null state was not accepted. Okay, so here we have taken an example. Here the initial state is A and the final state is B. So if we give 0, if we give 0 into A, it goes to B, which is our final state. And also if we give 0 to A, it creates a self loop, and then after 0 if we give 1, it also remains in the self loop. It self loop or A, it does not go to the final state. Okay, so here if we take L as a set of all strings that ends with 0, and we have taken two examples, like 100, this is a string which ends with 0, and 01, this is a string which does not ends with 0. Okay, so if here we take A as our initial state and we give 1, like here we have given 1. Okay, like here we have given 1, so it remains in the A. Okay, now if we give 0, there are two possible outcomes. Either it is self-centered and it remains in A, or it goes to B. Like here we have 0 and we have taken two next states which are A and B. Okay, now from after B we does not give any input. Okay, so it remains at null. Okay, but in A we give another input called 0. If we give A 0, then there are two possible next states which are A and B. Okay, so but if in B we give 0, then there is no next state, so it becomes null. Okay, in non-deterministic finite automata, null state is accepted. Okay, so here as B is arriving and here also we get B, so B is our final state and this string is accepted because we get our final state. But in 01 this string is not accepted. Okay, because if we give 0 in A, there are two possible outcomes, one is A and one is B. Now if we give 1 to A, then it becomes A. Here we have seen that if we give 1 to A, it is self-centered and it remains at A. Okay, but now if we have B, in here if we give 1, it becomes null. Okay, so here the final state which is B is not arriving, so here this string is not accepted. So now we know the uses of finite automata, which is finite automata is used to design the lexical analyzers. Lexical analysis is the first phase of preprocessors that are written in the form of sentences. The lexical analyzer breaks those syntaxes into a series of tokens by removing any white space or comments in the source code. An automata is useful of designing text editors, for designing and implementation of spell checkers, combination and sequential circuits using melee and mode machines, and it also can be used as a model for learning and decision making.